Now, in the matrix operations section, we talked about adding, subtraction, and scalar multiplication. And the reason that we have to be so clear in the two types of multiplication that we're talking about is because when I multiply two matrices together, it doesn't result in what you would think. So that's what this video is going to address. Actual matrix multiplication. What happens when I multiply one entire matrix by another matrix? Well, first of all, when you multiply matrix A times matrix B in this case, so if I wanted to multiply A times B, you first have to identify what is the order of the matrix. Matrix A is an M by N matrix, and matrix B is a different size. It is N by P. Okay? In order for me to be able to perform matrix multiplication, the column of matrix A has to be the same value, or is exactly the same size, for the row of matrix B. So matrix A column has to be the same as the row for matrix B, and once that requirement is met, I can go ahead and multiply them together. Oddly enough, the resulting size of A times B is going to be an M by P, or these outside values. So my resulting matrix will be an M by P matrix. Now that's a lot of letters, so let's see what actually happens when we multiply matrix A times B, and then if we do it going the opposite direction, B times A. So here I'm going to start out with this single matrix, or this matrix here. This is one row, 3 columns for A, and 3 rows, 1 column for B. So let's see what's going to happen if I were to multiply these together. So first I'm going to check. Matrix A is 1 row by 3 columns. Matrix B is 3 rows by 1 column. And what I said above, according to this idea right here, in order for me to be able to multiply A times B, I have to check and say, okay, if I'm multiplying, and let me write this down here, if I multiply A times B, so I'm going to rewrite this a little bit differently for us. A is a 1 by 3, B is a 3 by 1. To perform it in this manner, A times B, 3 and 3. So the inside and that number. So the column and the row had to be the same. Here they are. Since they are the same, we are good to go. Now, the resulting matrix will be a 1 by 1. That's going to be the size. So one number, when I multiply these guys together, is going to be the result of this product. Now, how do I go about multiplying them? Well, matrix multiplication is about a row times the corresponding column. And you just add them up. So row times column, okay? So how do I do that given A times B? So I'm going to just rewrite this as 2, -4, 1, and I'm going to multiply that times -5, 3, -1. Okay? And remember, we're going to end up with a 1 by 1 matrix. So what happens is I am going to take row 1 and I'm going to multiply it times column 1. Okay, so this becomes 2 times 5. Then I add that with still row number 1, okay, only this is going to now be multiplied by still column 1. Okay, so it's a row times a column. So row times column, add that to row times column. So plus 1 times -1. Now I'm adding all of this stuff together, so this would be 10 minus 12 minus 1, or in other words, negative 23, is the result when I multiply A times B. So that is matrix multiplication in this order. Now what happens, let's do it a different direction. What happens if I multiply B times A? Because in the world of real numbers, if I multiply 5 times 3, that's the same thing as 3 times 5. Multiplication is commutative in the real world, in real numbers. But what we're going to see when we do matrix multiplication is that's not the case. So if I'm multiplying in this order right here, let's go back and we're going to rewrite this. Remember that matrix B is a 3 by 1, right? We had it up here. It's 3 rows, 1 column. And matrix A was 1 row, 3 columns. So we have to check. The row and the column have to be the same number. They are the same number, so we're good to go. But the resulting matrix is going to end up being a 3 by 3 matrix. That's kind of odd, because when I multiplied A times B, the reverse order, I had a 1 by 1. This time I'm going to multiply B times A, and I'm going to end up with a 3 by 3. So let's rewrite matrix B, which is negative 5, 3, 1. And we're going to multiply that times matrix A, which is 2, 4, negative 4, 1. Remember, we're going to end up with something that's 3 by 3. So I said that matrix multiplication is about rows and columns. So I am going to multiply row 1 by column 1. So row 1 by column 1 would be negative 5 times 2, which would be 10. And I'm done with that position. Okay, now I'm going to go back and I'm going to multiply. Let me put those back in there. Now I'm going to multiply row 1, column 2. So row 1, column 2 would be 20. And finally, let's just finish this off. I go row 1, column 3. So row 1 is negative 5 times column 3 would be a negative 5. And that gave me, let me get these back, the first row of my product. And we start over. I have row 2, column 1. So row 2, column 1 is going to be 6. Now I have row 2, column 2. That's going to be negative 12. Row 2, column 3 would be positive 3. Okay, so you can see that we now have 2 rows of my 3 by 3. Finally, we're going to do row 3, column 1. So it's a repetitive process. You just have to remember the order. So 1 times 2 is 2. Row 3, column 2 would be negative 4. Row 3, column 3 would be positive 1. So you can see that when we multiplied B times A, we ended up with this 3 by 3 matrix as opposed to A times B, which is this 1 by 1 matrix. And that's how so order basically matters. Multiplication is not commutative at all.